Hi there, welcome back to my channel. In this video, I'll be taking you through the volume of a solid using the Walsh method. In our previous section, we used the Dix method to solve for the volume of a particular region, and in this video, I'll be showing you how we use the Walsh method of such problem. So now, when we say Walsh method, we trying to say that there will be a hole within our volume. Okay, so for the Dix method, it's going to be a complete volume. Okay, but for this one, there is going to be a hole. So let's see what happens. I have one function or one curve up, another curve down, in which the two functions are not touching the x-axis or the y-axis, right? If there is revolution, the smaller one or the one which is beneath will create its own hole, right? Then the bigger one will also create its own revolution. But you realize that the bigger one will cover up the beneath one, right? But the smaller one will create a hole within. Therefore, you get something like a tube-like shape. So here we don't have a complete solid figure, but here there is a hole within. So these are situations where you are given the area bounded by two different curves, right? Other than a curve and an x-axis or what? Y-axis, right? So that is when we use the Washer method. So the Washer method is simply defined as, so this is going to be what the volume of a cylinder, all right? But there will be an empty space within, and that empty space is accounted for by the difference between the two functions. That is our radii, because the bigger one will have a bigger radii, the smaller one will also have another radii. So when I subtract the two radii, I'm going to have the radii of the actual thickness, and that is what I'm interested. So here, instead of V is equal to pi r squared h, which is generally the volume of a cylinder, our radius is replaced by what? The difference r of x squared minus r of what? Small r of x squared. That is the difference between the two functions, and that is what that makes the difference. Our h is simply what? The change in what? X, and what? If probably it was against the y, it was revolve around the y. Here will be r of y, and y. As simple as that. So this is all about the Washer method. Nothing strange, nothing difficult, right? So let's see how you can use this to solve a problem. So I have an example here for us to solve. So you see, find the volume of the solid form. Find the volume of the solid form by revolving the region bounded by the graphs of y is equal to the square root of x and y is equal to s squared about the x-axis. So this is our simple problem here. So he said find the volume of a solid form by revolving the region bounded by the graphs of y is equal to the square root of x and y is equal to s squared. So you can clearly see that these are two curves, and you want to find the region, the volume that will be created after revolving the boundaries of this and this, right? So how do you do this? Let's do this one. You know that every boundary has a limit, right? So what would be our boundary points? So we need the upper and the lower limit of of our integration. I mean, where are we integrating from and to where, right? So what you do is you equate them because they will be meeting, right? For you to get your values, that is from this side and to this side. Okay, so let's see. So if you have square root of x is equal to s squared, what do? You square both sides, you're gonna get x is equal to x to the power 4. Is that not it? And I'll factorize x. Okay, x to the power 4 minus x will be equal to 0. X out, I'm going to have s cubed minus 1 is equal to 0. So I'll have my limit to be s is equal to 1, then x is equal to 0. So meaning our integration is going to be from 0 to 1. That is all. So that's the first step. The next thing is to ask yourself which one will be the inner function and which one will be the outer function, because they've given you these two functions. This is where your application